So in today's video we will be evaluating the integral of arc cosine of x or inverse cosine of x, whichever it is that you prefer, using a method called integration by parts, which follows the following formula: u times v minus the integral of v times du, where it is that u is an easily differentiable function that shows up somewhere in the integral, and then your v is going to be the integral of whatever it is that's left over if you cover up your u. So what I want to do in this particular case is I want to choose arc cosine of x to be my u. So u is equal to arc cosine of x. Therefore my v will be whatever it is that's left over if I were to cover it up. So if I were to cover up arc cosine of x, all I'd have left is the integral of dx. So v is the integral of dx, which is equal to x. Now the last piece that we need for this formula is the du, which is the derivative of our u. So du is the derivative of arc cosine of x, which is negative 1 over the square root of 1 minus x squared. Now all we got to do is we got to start plugging things into their place in the integration by parts formula. So u times v is going to be arc cosine of x times x. So let me just put that x out in front. So far we've got x arc cosine of x minus the integral of v times du. So this is going to be the integral of, our v is x, and then we have a du which is negative 1 over the square root of 1 minus x squared. So this will be x over the square root of 1 minus x squared, and because of this negative sign out in front, we can essentially pull it out and make this a plus. So far our integral looks like x arc cosine of x plus the integral of whatever it is that this will come out to. Forgot my dx. Whatever this is going to come out to, that's going to complete the integral. So all we need to do for this particular one is use a substitution, where it is that u will be 1 minus x squared, and our du will be the derivative of that. So u is equal to 1 minus x squared. Du will be negative 2x dx, and if we isolate for dx, dx is du divided by negative 2x. So if we wanted to evaluate this, we would have the integral of x, our dx is du divided by negative 2x, du divided by negative 2x, and then over the square root of what is our u. So this is the square root of u. So we can cancel these out. So all we've got left is a negative half, which we can pull out in front of the integral. So this will be negative a half times the integral of du over the square root of u. If we wanted to make that a exponent, we can make it u to the negative 1/2 because it's in the denominator. So this is u to the negative a half du. Picking up where it is that I left off, we have a negative 1/2 times the integral of u to the negative a half. All we need to do to evaluate this integral is raise the power by 1 and then divide by that same power. So u to the negative 1/2 plus 1 is u to the positive 1/2 divided by positive 1/2. Whenever it is that you're going to divide by 1/2, it's the exact same thing as multiplying by 2. So this becomes negative a half u to the positive half times 2. And here the 2's cancel out very nicely. So all we've got is negative 1 times u to the positive 1/2. So if we were to substitute that into our initial expression over here, we have x arc cosine of x plus the result of this integral, which is u negative u to the half. So this will be negative, and then our u is the square root of 1 minus x squared. Square root of 1 minus x squared. So this cancels out with this. This becomes a negative. So all we're left with is minus the square root of 1 minus x squared. And that completes this integration, so we're going to add on a plus c. And that is our final answer for the integral of arc cosine of x.